Hello, everyone, and welcome to today's SANS webcast, SEC642, Killing Snakes for Fun, Flask SSTIs and RCEs in Python. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Moses Frost, Certified SANS Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Moses.
Thanks, Carol. Thanks for the introduction. I hope you can hear me. Hi, everybody. Thank you for taking time out of your busy days, whether you're in the US time zones or globally, well, no matter what time it is. I appreciate you spending some time with us. So today I'm going to go over some material that I was excited about when we launched it about a year ago. And this is part of this actually is a piece of our advanced web app pen testing course, and I've added some additional slides to it. So as we enhance the course, you'll probably see more and more of these pieces showing up. What we're going to talk about today is we're going to talk about Flask. It's a Python framework if you've never seen it before. Specifically, we're going to talk about that particular framework, the Flask framework. We're going to talk about something called server-side template injections, or SSTIs, and how fun that is. But of course, if you're going to talk about Flask and SSTI, and you're going to take my class, you know that what you're going to want to do is take it from something that is readable or something that is kind of interesting to full-on shells, right? Because that's kind of what all the pen testers want, a way into an environment. So with that said, if you are here as a penetration tester, a web app pen tester, you want to learn about it, you're a developer. I've had a lot of developers come to the class, or you're some kind of a DevOps focused person, I think you'll find this to be kind of interesting. We are gonna level set with everybody, right? So because of the wide swath of people that come to some of these advanced classes, we are going to level set at the beginning with some of these technologies, but we'll do some demos, and I think you'll get fun out of this one. This is the obligatory slide with my information on it. So if you want to reach out to me after this, or if you have a question during the presentation, I'll try to keep an eye on that, I can review it later with everybody, and hopefully I can answer some of those questions. So with that said, what is today's agenda? So we're going to talk about Python in general. We're going to talk about the web and how Python is used on the web. Then we're going to talk about some Python frameworks. We're going to talk about templates and template injection. And then we're going to talk about something a little bit more advanced, something that many people may have not been exposed to, and that is the way that Python handles methods and method resolution order specifically. So we'll talk about how we can use method resolution order to basically do object injection, and then from there get execution, right? So we'll show you how to find that and how that kind of works. So let's talk about Python. A little bit of Python. So Python does come from Monty Python's Flying Circus. So if you're a fan of really dry British humor, I guess Guido von Rossen was a fan of really dry British humor. The one thing that made Python different or interesting from other technologies back then is that it was very simple, or made it appear very simple to allow you to script or create very complex programs without having to necessarily worry about all the underlying stuff, right? So if you think about the late 80s and the programming languages that were very popular in the late 80s, a lot of them were compiled. They required you to know how to allocate memory. And the contender here was something like Perl, which a lot of people did like Perl. The one thing about Perl that made it kind of difficult is that you could write very, very small, almost unreadable Perl that would work. With the one thing about Python was that you could write, or it would force you to write very clean code that maybe not the smallest, but is the most maintainable. And so because of that, it became very popular. So popular that almost every Linux distribution today, and it's still like this today, basically uses Python as the way to operate your applications, right? So, or to install the actual system. So all of the Linux installers, when you first install Linux, and all the ones that maintain the packages, are almost all universally written in Python. Even things like Ansible, universally written in Python. Google, when it first started, really started using Python and Java for a long time. So we could keep going on this, but it's a very, very popular language, right? Now, what we'll talk about how this impacts the web, but Python is a systems scripting, systems development language, right? So it wasn't thinking about the web as a first class priority, right? Because the World Wide Web really wasn't as big as it is now. So just keep that in mind, okay? Now, what happened to the other languages, right? So Perl had a very big issue transitioning from Perl 5 to 6. And so because of that, Perl no longer became vogue. Python, it's had its challenges transitioning from version 2 to version 3. So there was a time there where Python looked to go the way of Perl, right? And I bring this up because right now, if you look at it, Python 2, which is the longest lived version of Python currently, is about to go end of support, right? So end of life, end of support. So all this Python 2 code that's out there, if there's a security fix or something, it's no longer going to be maintained, right? So everybody's had to move their code, or should be moving their code, to Python 3. So Python 3 is the current version of Python. There was a lot of rather big, ugly changes from 2 to 3. The 3.0 adoption was rocky at best. Nowadays, Python 3 seems to be in a very good place. So, we've had Python 3 since 2008, but we've also had and maintained Python 2. And I put this in this like really badly drawn line graph to kind of just show you the length of time that each version has lived. So, you can see that there was some overlap between 1 and 2, but there was enormous overlap between 3 and 2. And so all this code that has to be upgraded now, it's going to take a while to work through that system on that. So you'll probably see a large amount of applications that will still be Python 2. But let's say for the current implementations that we're going to show today, we're going to use Python 3 as we should be, okay? So that's Python in a nutshell, right? That's everything I want to talk about Python. We're going to get into the code. Yeah, we're going to get into look at some code examples and everything, but I want to kind of give you a 5-minute thing on Python. Okay, so let's talk about Python and the web, okay? And we're going to be using this throughout the actual entire kind of reference, right? So how does this work? What does Python do, etc. So in the early days, Python really didn't have a good way of interfacing with web servers, okay? So in those days, what happened was that if you wanted to build a Python or Pythonic web server, you would have to have your application talk to a web server like Apache over some type of standardized channel, right? So the original standardized channel was CGI bin. That was a set of API calls that really, all these frameworks used. It was not the best. There was some definite security issues around CGI bin. So somebody created something called mod Python, right? And so what mod Python does is it installs a module in Apache, and that module actually talks to the Python application underneath. Well, the problem with this is that Apache is not the only web server that exists in an environment, right? Not even close. So you can have all sorts of different web servers that you may want to support, right? And so we're going to get back to this, but basically today, what the Python community has done is they have created something called WSGI, right? So it's a web server gateway interface. Okay, you may have heard of these. And what they do, or what it's designed to do, is that Apache, Nginx, IIS, Caddy, all of these web servers, they will proxy on a port to the WSGI server. There's many WSGI servers that exist. The one I put in this example was one called Waitress, which I believe is what the Flask folks tell you to do. And so what happens is Waitress opens up a port on 8080 localhost. Apache talks to Waitress. Waitress directly interacts with the underlying Python scripts to get you that web server process, right? So this is how a production Python application would be architected. Okay, now we're going to talk about why this is important in a minute, but understand that this is a foundational context for what we're going to do, because as we go through this application, you should know what the full architecture of one of these things look like so that you can understand how these things interact with each other. Okay, that's the idea. All right, so let's talk about Flask. The kind of meat of this, right? So Flask is a web server, or sorry, web application framework. Okay. Now, to understand what Flask is and why people use it, let's talk about how most of these web application servers actually operate. Okay. So the underlying architecture for many of these things is something called model view controller. Okay. Model view controller has been really promoted as a web framework or as a web technology by the folks over at Ruby on Rails, right? So model view controller is actually an architecture that draws its roots or was created by the folks over at Xerox PARC in the 80s and was very popular way of implementing GUI applications. Okay, so if you were designing a GUI, think of Microsoft Windows as a GUI, or OS X has Cocoa, or X Windows, right? If you think about that, model view controller actually was a way that they were designing these frameworks or these actual view states, right? Now, it just so happens that the programming language that was used in Xerox PARC to do this was a programming language called Smalltalk. You probably never heard of Smalltalk, but Ruby, the programming language that actually promoted model view controller and made it kind of as popular as it is, actually also draws a lot of its foundational knowledge from Smalltalk. Okay, so a lot of these things kind of seem to be ancestors to each other, right? So it's not surprising when you see it. Now, the reason we bring it up is because model view controller by far is the way that most of these web applications are designed, right? So when you're dealing with a standard framework application today on the web, whether that is struts or that is .NET MVC for model view controller, or that is even classic ASP.NET, Django, Rails, one of those, right? You're going to be looking at a system that more than likely will have a model view controller architecture. And so you have to bear that in mind. Now, where Flask fits into all this is that it is not a full-on batteries included model view controller framework. Okay, so when you install Django, when you install Ruby on Rails, when you install all of these heavy frameworks, there are many things that you must do, that you are kind of required to do, right? So if you look at why these things were created, like Ruby on Rails or Django or one of those, typically they were created as a large framework for web publishing, and they typically have some kind of a blog or bloggish kind of feel to them. Like Django was actually created by a newspaper publishing company, and it's a Python framework that gives you the ability to build almost like a WordPress interface, right? So you could do mailing lists, and you can email people, and you could take in text from a user and have it like come out as like a blog. It's a very good way of actually building many websites, but it doesn't tend to lend itself to everything, right? Very similar to how Ruby on Rails, a very good application framework, um, really can do a lot, and it brings a lot with it, right? But in today's age, there are architectures that lend themselves to wanting to be very thin and very light. And the reason for that is that developers have started to move all of their large application development infrastructures to this cloud environment, to the cloud. And because of that, they are starting to build more and more of these micro web frameworks in the cloud. And these micro web frameworks leave many things to be alternatives. As such, you're seeing things like Bottle, which is a small Python framework. You're seeing Node.js and Express.js. You're seeing Flask show up. Now, Flask can be a very, very powerful web framework, but it doesn't by default specify or demand from the administrator that they must do certain things. Okay, so every little Flask application that you see out there can be fairly different in how it works. All right, so and by the way, there are entire books on Flask. There's all this stuff that you can do, so it could be super complex, like when it comes to like blueprints and some of the ways to develop it. But for our conversation, let's talk about some lighter weight Flask implementations. Okay. Now, I see that there might be a question. Oh, yep. Just want to make sure that there was nobody asking a question. And by the way, if you do ask a question, I will be looking at them to make sure that I can answer them if I need to ahead of time while we're on something. So let's take a look at this. Let's say we have a Flask application, and to us, well, it could be as simple as this. Now, the one I'm going to show you here at the end of the class is as simple as this, more or less, right? But let's just say, okay, how does this actually work? So typically, you make a request into the Flask application, and it does more, okay? The application, when it gets its request, it looks and it says, okay, you're trying to go to the index of the web page. You're trying to go to the reader view of the web page. You're trying to go to the administrative level of the web page. In order for me to accomplish this task, let me look at my logic. Let me look at my controller layer and figure out what I have to do. Typically, when you talk to that controller layer, it says, oh, you know what I might need to get data from a database and push this data into some part of the application. So it just so happens that most, but not all, most Flask applications will interface to a database layer. Okay, we usually in a Python language, it's called SQL Alchemy. That's the driver that they use. If they don't use this driver, they're making the database calls directly to the database. And for those that are proficient in actual web application penetration testing, you would realize that calling the database directly could leave you open to SQL injection, right? So in this case, let's just say that they do this safely, and that they call the SQL Alchemy system safely, and then that calls the database and it returns data. Now that data has to be put on a web page, right? And this is where part of our talk today goes to, right? When the data gets pushed into a web page, we want to make sure that the web pages look and feel very similar, right? So we may run it through what we call a templating engine. and that's where we actually come into this talk, is how do the templating engines work effectively with these systems, and is there a chance for abuse? Okay, now I'm going to pause it here for a second because I ran through a ton of background information, and I want to make sure that so far everybody's good. So I'm just going to wait here for like 1 second to make sure that if you do have a question about any of this right now, they could be answered. If not, I will move to the next section, which gets a lot more technical.
Hi, Moses. I'm not seeing any questions at this time.
Perfect. All right, perfect. So let's take a look. And if you do write them and it takes us a minute to show up, we will stop and go back. But thank you. All right, so let's take a look at templates. So templates engines are very popular on the web, right? Super popular on the web. When you have to really understand what a template does in order for you to understand why they're so popular. So here's what templates typically look like, right? So here I've got this dynamic bit of code, which is like the obligatory hello world, right? And if we did not have a template at all, we would have to build every single HTML by hand inside of every function, okay? So we would have to return all the HTML code, all of the headers, all the body, all of the relevant data, all of it would have to be displayed for every function call, and dynamically built. Nobody would ever actually want to program this way because this actually would be a complete horror show to do. But we do actually see some of this stuff in the wild. Now, I wouldn't recommend anybody do this. I would definitely recommend doing, everybody using a template, but we do see stuff like this in the wild. And this is what you would have to do before like template engines and before frameworks were a thing. You would basically have to build every single web page dynamically from scratch without using any programming paradigms to do it, right? And so that's what it used to look like, and this would be ungodly to do if you had to do it now. Instead, what we decided to do as an industry is we decided to use Jinja, or something like a template Jinja. The one we're talking about is Jinja. Jinja templates, and for that matter, other types of templates, are used in many things, right? They are not just used in instead of a web framework environment, okay? The Jinja templates themselves appear inside of other Python systems. So what I'm showing you here is an example of the Ansible systems kind of configuration tool. Now, this would be a tool that a systems administrator could use to make sure that all of their Unix and Windows systems all look the same. So this is a way for you to build and maintain computers, not websites, right? But it just so happens that Ansible, having been written in Python, takes advantage of the Jinja template engine. Instead of using it for websites, they use it to actually change the actual files on the systems dynamically. So for example, let me show you how this looks, right? So for example, you would build a Jinja script or a little Jinja file somewhere on your file system that says welcome to, and then you have the closures, right? You have the two curly braces on each side and the word system underneath, right? And what's supposed to happen is that that word system would change depending on something, right? And so if you look at our little Ansible module, or a little fake Ansible module, what the Ansible module says is that wherever you see this variable system, look up the computer's hostname and then replace it for every system to whatever. So if you run this on the web server, when you log into the web server, the message of the day would say, welcome to web server. If you logged into the file server and the file server's host name is file server, then it would say, welcome to file server. And so you have this one file that you can use across a fleet of systems, right? So that's what a templating engine can do, whether it's a web page or not, right? That's the idea. And you can see how useful this is. Because if you're building web pages and you want to put in dynamic content, you have a way of replacing this stuff, right? It's very nice, very, very malleable, okay? So with that said, is there more than just one template engine, right? Like, because we talk about Jinja, but why Jinja? Well, it just so happens that there is, okay? Every framework has a specific templating engine, okay? There you can, under certain conditions and with certain frameworks, specify a different template. So you might be able to use a different template engine, so, template system in a different web framework. It just so happens that Flask defaults to Jinja templates. Okay. Now the templating engines themselves are usually written in the programming language that you are running your application in. It doesn't have to be, but it makes sense, right? And as such, they are, in their own respect, applications that can execute code. And so, what I'm going to show you in this example is a pre-sandbox version of Flask and Jinja specifically. There are sandboxed versions of Jinja that what you would have to do is you would have to escape the sandbox before executing code. And so the first question you would say is, well, has there been sandbox escapes? And the answer there is yes. There has been ways to escape the sandboxes, and you learn about this through class, right? You actually learn what a sandbox is and how to escape it. All depends on the type of sandbox and what they're doing, right? Now, we don't teach universal sandbox escapes always, because sandbox escaping or some kind of exploitation of this nature is always going to be patched. So if I say, yeah, we have a 0-day sandbox escape, bug in class, by the time the class runs, there could be a fix for it. And so the latest version of Jinja may already have patched that for that particular bug. Instead, we show you what is possible in one lab, and then we'll show you sandbox escape in another lab. And in the wild, then it becomes all dependent on the versions of software they're using and whether or not sandbox escaping is potential, right? Because all of this stuff is dependent on things like versions and string concatenation and the like. Okay, so with that said, what engines are out there? So it depends on what it is you want to look for. So some languages or some frameworks like ASP.NET will use web forms, and maybe Java will use JSP, and PHP will use Smarty and the like, right? So depending on the type of template, your special character code delimiter is going to be different. Now, if you look very carefully on the screen, you're going to see the reusability of particular characters inside of a template engine, right? So commonly you might see curly brace, or you might see curly brace and two curly braces, or you might see percent, you might see $sign, you might see @sign, you might see percent equals. So all of these things are potential, right? What you would do in the course of fuzzing your application is you would go engine by kind of like a sample code by sample code, line by line, and you would try to figure this out. Now, there is a tool that does this for you, right? There are tools that will attempt to do the discovery part. Exploitation is a little bit different, right? So exploitation becomes kind of it depends, right? Because it depends on sandbox. It depends on what it is you're doing. Now, you might see some familiar languages on the left-hand side, or frameworks, right? So it's language or framework that is more appropriate. So, you might see things like JavaScript generically instead of Node.js. You might see Ruby on Rails generically, Python having all the different Python implementations, PHP Java and ASP.NET. There are other languages and there are other template engines, right? We could not fit them all in here, but just understand that all of them kind of sort of work the same. And so discovery is not as challenging as exploitation. That becomes a little more challenging. Okay, so with that said, let's talk about what this looks like, right? So let's say that you had a definition here for Flask. And what's going on here, and I'll sit down and I'll explain this for you very carefully, right? So what's going on here in this particular version of Jinja is you have a tuple, right? So you've got this like a dictionary of items, right? So you have a key and a value and a key and a value and a key and a value everywhere, right? So you have this thing, it says people. So you got different people that are being shown up. If in the actual GET request, okay, you pass in the right key, so for example, Bob with a capital B, Matt with a capital M, then what Jinja will do, or what actual Python system would do, right, is that Python would look inside of people. You would actually go through it person by person, and looking for the names. If you match on Bob or if you match on Matt, then all it would do is append hi Bob or hi Matt to the actual template, right? And if you look at template equals, which is right here, the problem with this entire thing, which is why they created Sandbox, is actually, let's see if I can actually, no, I want to do pen here. So the problem with this whole thing is here, okay? So what we're seeing here is an unrestricted, completely unredacted, there's nothing going on here. Whatever the actual application is seeing on the actual GET request is being copied and grabbed and hung onto the template. Now the template engine will try to render this, okay? The right way of rendering this is by just saying, Bob. But what happens if you start using special characters? Well, there's no restriction here on the use of special character. So when the template engine goes to render this, right, it hangs the request in the engine and will process it as if it came from the developer. That would be the problem here, okay? Now I see we have a question on the line here. Let me just make sure I handle it. Oh, no questions. Good. Cool. All right. So that's the crux of this issue, right? So this is what the background code is to look for. Now, how do we actually discover this in the wild, right? Because you got to figure out a way to discover this. Now, there was a lot of folks that did work on this. I believe James Kettle over at Burp Suite, he had a great presentation on this initially on how to look at SSTI and how to find it. And what I think one of the papers that he wrote, I'm pretty sure one of the papers he wrote, they just did mathematical computations to try to discover this. Now we have an actual application here that we could show you. We'll do that here in a minute. But you could see that, hey, if we pass an @ sign and we do math, or if we pass $, or double curly braces, or some curly brace dollar derivative, we might get execution. What's really interesting is that some of the execution logic will either be a PHP based application like Twig or Mustache, or Python, right? So that's the more interesting thing, is that you could be dealing with one language or another, but you won't know necessarily which language you're going to deal with, because there's an overuse inside of the programming paradigms between the curly braces and say the angle brackets and the percent equals, right? So just bear in mind that once you figure out that this is possible, you're going to have to do some further work to figure out what the language underneath is. Very similar to SQL injection, right? You know that there's SQL injection, but you don't know what kind of database there is yet to actually make your injection an exploit, all right? Like a real working exploit, okay? Now let me show you we have a sample app that we can show you. So here we have a sample app. Let me just erase this here. That's for later. Here's our little sample app. This is actually the app that we use in class. We run it through Burp just so that you can see that can be run through burp, with the request response headers. Now, you could just say, hey, I have a book. All you got to do is feed it a book, right? And you see it says here, book is equal to example plus book. So example book shows you this, right? Now, it's like, well, the first challenge here is, can you get a book name, right? Can you do that, right? Because it says here books equals book. You just got to give it a book. So if the book is here, just pass it a book. All right, seems harmless, right? So let's do that. Let's actually go in here and say, okay, well, book is equal to, and I forget how. Let's see how we do this one. I think it's name. Let's see if we do name. Sorry. Oh, let's do this. Equal to name. Nothing. Well, it's really more like book.name. Ooh, sorry, books.name. Right? So, books.name calls us mostly harmless. So why is that? Well, what we're doing is we're actually going into books and saying, I don't want all this. I just want this name, right? And so that's how we can get this to equal this name. Now we could even go in here so far as to say, hey, books.flag could give us a flag. Now in most classes, right, we're used to seeing that and going, hey, you know what, this looks like an interesting character. Let's see what this looks like over here. Books.flag. Well, it looks like books.flag has got this base64 encoded string. So you could take this base64 encoded string, send it over to decoder, and kind of decode the string, right? So it looks like base64, and so you could just kind of see like what the flag is, right? So just for fun, right? Now, how do we discover this, right? So let's talk about this discovery. So how do we discover that we have even this potential, right? So what we could do is we could do things like, well, let's take a look at the slide, right? Is it a razor, right? Is this going to work, right? Nope, that's not going to work. Is it free marker, right? So can we just do something more like this, right? Nope, that's not going to work. Is it, we know what it's going to be, Ginger, right? So is it one of the other ones, right? 6 times 7, no, that's, oh God, no, that's not going to work. That's definitely not going to work, right? So is it this, right? 6 times 7. And look, it's 42, right? Somebody did math in this, right? Somebody actually has done the mathematical computations in here. Yeah, so we do have a question, by the way. So there's a gentleman with a question that says, STIs patched or prevented by the template engines themselves. So the answer is yes and no. Okay, so this particular exploit is totally a possibility because they are hanging the actual percent. They're basically, if you look at it here, let me go back a little bit. This here is the problem. You're not supposed to do string interpolation anymore, right? What Jinja wants you to do is they want you to take the strings that are hanging off of the templates and pass them in as objects natively. But instead, what the developer has chosen to do here is a little bit older. They are taking the actual strings in the URL bar or in the post, and they are passing it as string values or concatenating them as string values, so the template engines cannot understand whether this is a string or whether this is code. Okay, so for this particular example, the right way of doing this is to change the way that the developer has implemented this function so that it is actually safe. Okay, now if you find that they are using the safe way of doing it and a sandbox escape is found to where you can exit the Jinja sandbox and execute code, then that is going to have to be addressed by the developer of Jinja. Okay, and there have been Jinja Sandbox Escapes, okay, that have existed. All right, for those that are interested in this, my recommendation is to start to Google, Jinja Sandbox Escape, and you will find some CVE numbers and some older Sandbox Escapes that have existed. Like this one no longer works. This first one here no longer works. It was created 5 years ago. Okay, and this one basically um, escapes the sandbox, right? Rendering the context and rendering a way of getting out of the sandbox. I will paste this in the chat, and I will leave this inside the PDF so you can look at it. This is this particular one was already addressed in the Jinja framework, but it is an example of how you can do it. Anyway, so we have that. Let's see. Okay, so now let's switch gears here for a minute. So now we have found a Jinja sandbox, or sorry, a Jinja string kind of escaping area, right? How can we take what we found and start to go further with it? Okay, so the first thing I'm going to talk about is classes and rating internal values. Okay, so every programming language, well, not every single one, but every object-oriented programming language will or should implement some way of recognizing the class values that you have. Okay, so as an example, if in Python and specifically in Jinja, I pass the self-referencing object or the class, or I pass the variables into a template injection area, I should be able to read everything about this class. All right. Python and Jinja do this. Ruby and Ruby on Rails does this to where you could read all the methods that are being inherited by the class. And we're going to show you method inheritance in a minute, but this is how you trigger method inheritance and being able to read these values. Okay. Now, because method inheritance and the ability for you to read these values exists, you should realize that many of the languages you deal with also allow you to run operating system processes within the application. So here is an example of rendering code execution depending on the language underneath. So you have famously in Python 2 or 3, you have the ability to call subprocess as a class. And from subprocess, you can do a popen. In Ruby, it's IO. And in Java, it's Java lang runtime exec is the default executable. In Ruby, by the way, in the Ruby shell, if you do backticks, you will do the system command. It will use IO. It's kind of just a shortcut in Ruby to do it. It's kind of nice. But if we can call these classes, or if we can somehow get our code to recall these classes, we can run operating system commands, right? So for example, if we can somehow figure out how to go from books in our last example over to subprocess, we can run operating system commands. We just have to know how to go from books to subprocess. Okay, so that's what we're going to talk about right now. So how do we do this? So first of all, Python has something called method resolution order. So let's talk about how this works. So in Python, you have what's called reserved names. So you have function or class names that you should not or cannot use unless you are part of the system defined classes, right? Or the private classes. So in other words, underbar something, underbar is something that the Python language has as a private system defined class, right? So underbar main is the main function of your application. So if you've ever seen that in Python, you've seen underbar, underbar, main, underbar, underbar. That's something that Python uses as an entry point, okay? Underbar, underbar, and something are just private classes. So just keep that in mind, all right? Now, when Python goes to actually resolve objects, it has to resolve objects in search order kind of thing. Now, think about when you are on your operating system and you're trying to recall a DLL or an executable, your operating system will look at the path that it's in and it'll say, oh, is this running from C, Windows, System32? Is it running from this other, C program files, etc.? Or if you're in Linux, is it running from bin or user lib, user bin, etc., right? So Python has the same kind of thing, but for objects and for classes, okay? So what Python says is, okay, I want to be able to resolve an actual object or a class. So and the way that they do this is actually something, if you're that interested in it, it's something called C3 linearization algorithm. And so what it says is a child precedes their parents, and a class inherits from multiple classes. If it's doing this, they're kept in the order specified by the base. Okay, so for example, in our example here, when I call the MRO of C, C is inheriting B, B is inheriting A. Oh, and by the way, because B has an object of D, it's also inheriting D, right? So all of these things are there for me to use when I call C. Okay, so that's kind of how this works. All right, that's not kind of how this works. This is exactly how this works. I'm sorry, I shouldn't have said kind of. That's exactly how this works, right? So I just have to figure out how to push this in, right? So here's an example of how to do it. And I'm going to do this. Now I'm going to do this particular thing literally in our application so you could see it in real time. Okay, so let's take a look at this, right? So knowing some things, I should be able to do this, right? So first of all, if I call self, I can see that I am a template object, okay? And I'm referencing nothing. If I call this underbar, underbar class, underbar, underbar, I can see that what I'm calling is a string, okay? It's a string, all right? Now, calling a string may not mean much because I don't know what a string does, right? It's just a string value, right? I know what it does, it just doesn't give me execution. So if I call method resolution order on a string, I get multiple things now. I get string, I get the base string that came from string, and I get object, okay? So I get object. Now, object is very powerful because objects are all the objects, all of them, okay? So I want to use just object, and I can do that. I can specify a 2, right? So 0, 1, 2, this is the third thing that I want. So I specify object, and I say, well, now I want object, but what I really want is everything about the objects. So I can do subclasses. And, hold on, I forgot a dot. Dot subclasses. 2 S's, my mistake. Here we go. So these are all of the subclasses of an object, right? It's a lot of objects, by the way. It's a lot of objects in here, okay? So all of these objects are now available to me to use. That's how this works, okay? I just have to find the object that allows me to execute code, right? So which one? And now, by the way, we can go one by one in here. And if you look, there's like subprocess, MP open, right? Now it's in the middle of all this. So you're gonna have to go, is it number 1? Is it number 2? Is it number 3? Is it number 4? You could put this in burp, right? So you can put this in burp and go, I want to call, object 1. I want to call object 2. I want to call object 3. I want to call object 4. And you could just keep going until you find the object that would call P open, right? And we actually do this in a class, right? We have the machine ping you, and we have them try to get a netcat shell, or we try to, okay? But netcat shells doesn't work this way, because one of the things you start realizing when you do this is that putting something like this within an object class breaks. So you cannot actually do this. All right. So unfortunately, those that have ever seen this is a way for you to get a netcat shell through a Python import process, but it doesn't actually work if you try it. I give you a different way of doing it. Okay. So here is a much more interesting way of doing it. What we can do is I can find the subclass number 40, which is actually, and you can see what it is here, file. So I can do a file. What can I do with a file? I can write a shell. What is in my shell? An actual way of bringing in this connection. But now we have another problem. Okay, the shell that I'm writing is a config file. It's not a Python executable. But this particular shell file, this config file, is a Flask specific injection. Why? Because in one command, I write a shell to the file system in the temp directory, and in another command, I tell Flask to configure itself using this shell script or this config file. By doing that, Flask will actually run subprocess call, opening up a raw socket to me, and I will get a shell. And that's how you get an RCE in Flask. So let me kind of show you how this works. Okay, so here we have our books. Our books, yeah, I won't discard my annotations. Oh no! All right, give me a second. Discarded my annotations. Let me show you how this works. So let's do this command. So this is actually the 40 right out of shell, call the shell, right? So I actually have it here in a script because it would be way too hard to copy and paste this, from PowerPoint. It's just a mess. Let's copy this out. Let's put this in here. So first thing we're gonna do is write out a file. Gotta write it. Okay, it looks like we wrote a file. We don't know until we recall it. Okay, so now we're gonna try to execute it. Now, in order for us to execute this, we need to set up our listener. Oh, and you know what? I wrote the file wrong because this is not the IP address of my system right now. So let's try to get that. So it will be 4 dot en1, no, en0. And by the way, yes, you can use whatever operating system you want to your little heart's content. But now, if you're going to use Mac doesn't ship with netcat anymore. So what I did was I installed NCAT, right? The NCAT listener. So got that. We're listening on 1, 2, 3, 4. All right, cool. So now let's do this. Let's write a new one because you gotta write it. All right. Okay, there we go. And now let's recall it. Now, do I get a shell? I don't know. It's kind of like, watch this. No idea. Let's take a look. Hey! Not a TTY, but that's okay. That's okay. I got my shell. I got my remote code execution. I got my connect back shell. I'm on the box, right, effectively. I think that this is actually a pretty fair way of doing this, right? So there you go. You went from a file reader bug, right? Because that's what this was originally, right? I was able to read objects and read files off of the disk to writing a shell and having the system execute the shell back to me, right? So those are the kind of things that we teach in 642. If you like this kind of stuff, this kind of web application testing, this kind of deep level stuff, this is the kind of things you get from this class. We do talk about template map and things. It's okay. It's not going to necessarily do everything you want it to do, but there's sometimes you can get a shell to execute. Now with that, we have 5 minutes. I did a little demo. I'm going to leave this up on the board. If you have any questions for me, feel free to either put them in the chat, email me, tweet at me, or whatever. And with that, I kind of leave you. So thank you everybody for attending, and I will open it up for Q&A.
All right, thanks, Moses, for that great presentation. If anyone has a question, put it into the questions window. We had one come in. It says, are SSTIs easily patched or prevented by the template engines themselves once these bugs are found?
Yeah, we answered that one when it came in the chat. So yeah, the
Oh, my
answer was
apologies.
yep, it's fine.
Well, I don't see any others that have come in. Well, thank you so much, Moses, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast. And Moses, really quick, we've gotten several pieces of feedback. One says, thank you, thanks, Moses, and great presentation, Moses.
Well, thanks, guys. Thanks, everybody, for attending. Hope to see you somewhere. Find me at a conference, find me at a SANS event, say hi. I don't bite much. And that's it.
All right, thank you.